In this video, I will explain you second experiment, both in machine language and assembly language. Decimal addition of two numbers. So how we can add two numbers, two decimal numbers by using 8085 microprocessor, and for the addition, we can program in assembly language or in machine language. So first I will explain you the assembly language programming for addition of two numbers. Okay, and then after I will explain or I will show you how you can use corresponding hex codes to program in machine language. So the first column, this one, it is the addresses. So from 2000 to 200C, we have addresses. At 2000, we are taking as the first data address. So the first data we can take anything. Now, for example, I can take 38. That is the first decimal number, and the second decimal number I can take 45. Okay, 45, and the result we will get here at 2002. So these two numbers we have to add. So for this addition, we have to use the first one. So here the first instruction which is used in this LXI H2000. So LXI H2000, what it does, it simply loads HL pair with 2000. Okay, so and it loads HL pair with 2000, and whatever we have in HL pair, that acts as memory. So memory meaning this 2000 will become as memory. Okay, it means from now onwards, so whenever we refer memory M, so that it will be the address 2000. So this one is 3-byte instruction. So that's why from 2000 directly it is jumping to 2006. Okay, so when I will explain you corresponding hex code, at that time I will show you that how 2003, 2004, 2005, what different codes are saved, or what different hex codes are stored at those memory locations. Okay, so this one is a 3-byte instruction. So next instruction that is given, move A, M. What this instruction does, move A, M meaning moving the content of the memory M to the accumulator. So M meaning this 2000. So whatever we have in 2000, that it will go to the accumulator. So in 2000 we have 38. So after this instruction we will get accumulator 38. Okay. Then after next instruction given, INX H. INX H, it means increment HL pair. H here meaning referring HL pair. So INX H meaning increment HL pair by 1. So here we will get increment HL pair. So I can write an HL pair. It will become 2. Here it was 2000. So now it will become 2001. And whatever it is HL pair, that it is M. So from now onwards, so whenever we say memory, so that it will be 2001. So next instruction given, add M. Add M means add the content of the memory to the accumulator. So the content of the memory means M means 2001. So whatever we have in 2001, here you see 45, that it is going to add to the content of the accumulator. In the accumulator we have 38. So here we will get 38 plus 45. Okay. So now you have to keep in mind, so 38 and 45 both are hexadecimal now, because whatever numbers or whatever codes we enter in 8085, that it is in hexadecimal. It means the microprocessor understands that as hexadecimal and processes accordingly. Okay, means by treating the data or numbers in hexadecimal, the microprocessor processes whether it is addition, subtraction, multiplication, those all things are done in hexadecimal. Okay, so here addition, so directly we cannot write down 38 plus 45 equals 83. You cannot write directly. Okay. So result here we will get, here result we will get 83 in decimal, sorry decimal not, result we will get 83, but here we will not get 83. Why? Because these two numbers are in hexadecimal. This one also it is in hexadecimal, then this one is also in hexadecimal. So we have to add these two numbers in hexadecimal. Okay. So when we add these two numbers in hexadecimal, so when you add, so you will get a 7D. What you will get? The result you will get 7D in hexadecimal. Okay. So 7D is not the decimal number, but we have to get the result in decimal. Processes are going on in hexadecimal only, but the value we have to get, means corresponding value in decimal we have to get. So for that we have used here DAA instruction, that is decimal adjust accumulator. Okay. So what it does, it adjusts the content of the accumulator to get corresponding decimal value. For example, if any value, or if any digit it is in decimal also and in hexadecimal, both are same. For example, 7 it is same for both hexadecimal and decimal, so that's why there will be no change. But D is not present in decimal. Okay. So whenever any digit it is going to be greater than 9, then in that case what this instruction DAA does, it adds 6. Okay, what it does, it adds 6 to that corresponding hexadecimal digit. So for example here 7D, so this will add, this instruction will add here 6. Okay, so we will get 6 and D. So the processes are going on. Means here you can write a corresponding binary also. For example, corresponding binary for 7 we have 0, 1, 1. Okay, 1. And for D we have 1, 1, 0, 1. So we have to, we are going here 6 will be added, plus 6. Okay. So 6 meaning what it is? 0, 0, 1, 1. If we add, so then you will get 0 here, 1, 1, 1, 0. So here it will come, so 0, and here it will come and 0, 0. Sorry. Not 1, 1, 0. 1 it will come here, so 1, 1, 0, then 1 it will come here. Okay. Okay, wait a minute, 7. Okay, 1, 1, 0, 1. 6 meaning 0, 1, 1, 0. That is 6. So 1, 1. Here it will become 0, 0, and here it will come 1, sorry, 0, then again 0, 0, 1, that it will come. Okay. When we add here, so what you will get here? 3 and 8. The result you are getting only in hexadecimal. But since we entered by assuming that numbers we are giving in decimal, so the result whatever we will get, that it is in decimal. So here 83 we will get. Okay. So this one, this is for 8 and this part it is for 3. So that's why 83 means 83. Okay. Result there on this display, you will get 83. So this process done. Then after INXH, what it does, again incrementing the HL pair by 1. So now you see here it is HL pair 2001. So when we increment 2001 by 1, so we will get HL 2002. It means that it will act as memory. Okay. Next instruction, move M, A. Move M, A, moving the content of the accumulator to memory. So now here it will become memory meaning this one 2002. So 2 memory it will become 2002, and this content of the accumulator. Content of the accumulator means this is 83. So here 83 we will get. Okay. At 2002. So that's why the result at 2002 we are getting 83. And this one here it is for you can say stopping or halting the processor to further execute the next instruction or further processing the next instruction. You can use HLT or RST5. So that is the whole process which is going on here. So one thing you have to keep in your mind, when the digit it will become greater than 9, only we have to add 6, and if it is 9 or less than 9, then we are not going to, because then decimal or hexadecimal will look like, you can say, will look like same. So that's why there will not be anything, because if I return 2 3, okay, or in decimal or in hexadecimal will look like same until I write down the subscript. If I don't write here in the subscript H, if I write in H, it means that is representing hexadecimal. Okay. For example, if I am not writing here in the subscript H, means you can treat that as decimal also or hexadecimal also. But when we write an H in subscript, then that it is used for hexadecimal numbers. Okay. So this is the assembly language programming for decimal addition of two numbers in 8085 microprocessor. So this is the second experiment of microprocessor lab, and the corresponding hex codes. So corresponding hex codes, because when you are going to program the microprocessor in machine language, then you need corresponding hex codes of these all instructions. So for LXI, what we have 21, and first this one will be the address, memory address. So address we write down in reverse order. Means first we write down LSB this one 00. Then after we write down MSB, that is 20. Okay. Then we have next move A comma M. For move A comma M, we have A comma M, that is 7E. The corresponding hex code we have 7E. Then for INXH, the corresponding hex code we have 23. And then for add M, we have 86. For DAA, instruction, and that is hex code we have 27. Then again INXH, same code 23. For move M comma A, we have 77, and for HLT halt we have 76. Okay. I think that is the corresponding hex codes. So I think this is the whole program for the second experiment.